Okay, so looking at this series, if I were to put a seven, let's say if I were to put a seven into this x, if I were to put a seven into the x, will this series converge or will it diverge? Or if I were to put, let's say, 38 into the x. Remember, it is only the n that's moving. Once we put something into the x, it stays fixed, and it then only n will move from 1 to infinity. So if I were to put it, let's say, a 38 into the x here, will this series converge or will it diverge? So in this video, we're going to use the ratio test to examine this. To examine what we can put into the x, and will it diverge or will it converge or will it diverge? So we are going to use the ratio test to examine this. So looking at this with the ratio test, we always want to know this value here. We always want to know the next term divided by the current term. So the next term will be us putting n plus 1 into wherever there's an n, So when you put n plus 1 into this n here, it will be x to the power of n plus 1. When you put n plus 1 into this n factorial, it will be n plus 1 factorial. So this an plus 1 will be this, and then this an here will be this. So now just tidy this up. Here you've got one fraction divided by another fraction. That's the same as you getting that same fraction and multiplying the reciprocal. So now it's just top. Here we need to tidy this up now. So hang on. So to tidy this up, visualize this as a block of x to the power of n times x to the power of 1. So remember, x to the power of a times x to the power of b, that's the same as x to the power of a plus b. So this is n plus 1. So break it up. So I'll break this up as one block, multiplying another block, and n factorial. You can break this up as this, because if you look at 5 factorial, 5 times 4 times 3 times 2 times 1, if this is n factorial, then n plus 1 will be one notch higher than this. So it would be 6 times 5 times 4 times 3 times 2 times 1, and then these two will cancel each other out. All that would be left would be n plus 1. Okay, so well, the point here is that you can rewrite this as being 6 times n factorial in our example. So this here is n factorial, and then you can write, well, this thing here is this. Well, I hope you can follow that. So this thing here can be rewritten as n plus 1 times n factorial. So now this will cancel out with this, and then this will cancel out with this. So all that would be left will be x to the power of 1, which is x, and then you've got your n plus 1. So it equals n plus 1. So after all that, if you use a ratio test, this value here will be this. Now looking at this, if you were to put a 7 into here, then this would be 7 over n. Now as n heads towards infinity, the denominator will just get bigger and bigger and bigger, meaning the limit of this whole thing here will be 0, because this will stay fixed. So when you put 7 into here, n will just get, as n heads towards infinity, the denominator will just get bigger and bigger and bigger. So the whole thing here will head towards 0. Well, if it heads towards 0, then we know the original series will converge. If you put let's say 38 into here, then this will be 38. Now, as n gets bigger and bigger and bigger, the denominator will just getting bigger and bigger, making the overall thing here head towards 0. So you know, the limit of this being 0 would mean that the original series will converge. In fact, you can put any number into here, and then it will converge. Okay.